Hello everyone. So in this video, I'm gonna show how you can create your own function block. So you want to create your own function block when you want to encapsulate a certain part of your code. So whenever you need to call that function again, there'll be no need to actually write that part of your program. So instead, you can just call a new instance of your function block and give it some new inputs and outputs. So let's say we have an application where we need to control multiple VFDs. Instead of writing multiple VFDs program, we can just write function block which is meant to control a VFD, and we can call multiple instances of these function blocks on our program. So let's see how we can do this on MasterTool. So to create our own function block here on MasterTool, we need to right click on the application or inside of some folder. I'm going to right click on the application and I'm adding a new object, and this object will be a program organization unit, a POU. This POU will be a function block. Let's call that function block VFD underscore FB. So to declare the variables inside of my VFD FB, my inputs and outputs, I will exchange the language to the textual mode. Okay, here you have your var inputs and your var outputs. So let's say for this VFD, I want to have a simple HMI start, which will be a Boolean type, and I have an HMI stop, which is also a Boolean type, and I have an HMI speed. It will be like an int, so the user can pass the speed of my VFD through an HMI. And here on my var output, if you remember, we have already created a structure that's called VFD. So I can call this output VFD, and the type of this variable is going to be VFD. So we can create an instance of a VFD and assign to my output. Okay, now let's create the simple logic for this VFD. I'm going to use a normally open contact and a coil, and I have my HMI start, and here I'm going to have my output VFD control word, and let's say that this VFD we need to set the bit 0 to the logical value 1 in order to start. Let's call another variable that is HMI stop, and I'm going to do the same, but I'll exchange the bit to 1. And for my speed, let's call another network, and I'm gonna place a move block here, so I can move my HMI speed to my output VFD speed reference. So it's pretty straightforward. I don't actually intend to use that kind of function blocks with this logic in a real project. It's just to show the idea. So here on our user PRD, we can create a new network, and I can call a new instance of my function block. I'm gonna click on my toolbox, and so I can call an instance of this function block. This is a poll, so I can expand the poll section here, and you can see here my VFD underscore FB. I can call this. It is a function block, so you generate a new variable. It is an instance that represents that particular function block. Let's press enter and declare this variable. That is the type of VFD underscore FB. I'm gonna erase this previous network that we used on the previous video. Let's connect our variable HMI start, HMI stop. I'm gonna create a new variable called HMI speed, which is the integer type, and our output VFD, it is the VFD type. So I already have a variable of type VFD, so I'm connecting this variable to the function block. Okay, so now let's log in and test our program. Okay, so you can see here that my HMI stop has already a true value. So if I expand my VFD sector 1 variable, you can see that my control word is true. Okay, that's it's meant to be like this. Let's write false on our HMI stop. My control word will be 0. If I start this, my control word is going to be 1. And if I write speed on my HMI speed, like 60 hertz, you can write 60 hertz on your speed reference. So I can map this variable on Modbus, and I can control this VFD through the Modbus network. And if I need to control a series of VFDs, so I can call multiple instances of the same function block and give them some new inputs and some new outputs.